Welcome back again, dear students, grade 8. How are you? I loved you and I missed you. Today, guys, we will start with lesson 3, a new lesson of chapter 5, using congruent triangle. This is the name of lesson 3. We will discuss two things, but in this video, we will discuss only the first part, using corresponding parts. You will see this abbreviation CPCTC. Let we know what is the meaning of this abbreviation. It means corresponding parts into two congruent triangles are congruent. C is the corresponding P parts, C congruent, T triangles, and the last C is congruent. So we have corresponding parts into two congruent triangles are congruent. Let me discuss your example on your book on page 182. As you see here, guys, we have a quadrilateral shape, GEDF, but actually, if you focus, we have two triangles. Yes, GED and GFD. And it's given that this line and this line, GE or EG and DF, are parallel, and they are what? And they are congruent, as it is clear on the figure. He wants from us to prove that ED and GF are parallel. So, ED and GF, we have to prove them that they are what? Parallel. If you remember, guys, before we have, we studied something we call it converse of apostolate. And one of them, it was converse of alternate interior angles. It said, yes, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So we will use that EG and DF are parallel. Yes, EG and FD are parallel to prove that ED and GF are parallel. Okay, so let me start, guys. We have two given things. What are they? As we said, EG and DF are congruent and EG and DF are parallel. This is given, as we said in the beginning. Yes, here are, we have EG and DF are parallel and they are congruent on the same time. If you focus, guys, on our figure, yes, what did you notice? Yes, there is a transversal. Yes, excellent, guys. As you see, the transversal is GD, and we have what? Two parallel lines. GE and FD, yes, are parallel lines, and the transversal GD, yes, is a transversal, cuts these two parallel lines, GE and FD. So, guys, as we say that GD is the transversal, as we have it here. Yes, guys, GD is the transversal, cuts these two lines, GE and FD. So, number one, we have these two given things. Now, number three, what we can say, because of GD is the transversal, that the angle EGD is congruent to FDG. EGD, let me draw it. EGD, it means, yes, guys, this one. EGD, yes, EGD is congruent to FDG. Let me draw it again. FDG, yes. Yes, guys, you are right. So, yes, guys. So this angle is congruent to this angle, and we know, I think you will figure the reason. Yes, because they are alternate interior angles. So, number four, we have GD is congruent to GD, which means the transversals. Of course, we are talking about the triangle GED and FDG, this triangle and this triangle. So, GD is congruent to GD is the common side. So till now we have number one and number two are given. Number three, because we have GT is the transversal, so we have these two angles are congruent, they are alternate interior angles. We know which angles, The first one is EGD is congruent to FDG. Why? Because we have the transversal, and number 4 we have GD is equal to GD is the common side. Let me continue after number 4. So guys, from 1, 3, 4, it's clear that these two triangles are congruent by using side angle side congruence. So the triangle EGD is congruent to triangle FDGY by using side angle side congruence. It's so clear. Side angle side, side angle side. And the important thing, if you remember, yes, we have the included angle. The angle EGD is included between the side EG and GD, and again the angle FDG is included between FD and GD. So guys, as we said that these two triangles GED and GDF or FDG are what are? Yes, are congruent triangles, and we say that we prove them by using side angle side congruence, and it's clear side angle side and side angle side. And we say the important thing that the angle EGD is included between GE and GD, and the angle FDG is included, yes, between the sides FD and GD. So from all of these guys, what we have an important thing that, yes, these two angles, after we prove that the triangles EGD and FDG are congruent triangles by using side angle side, so we can use what we call it, yes, where it is, here it is, corresponding parts and two congruent triangles are congruent. That means if we prove that these two triangles, yes, they are congruent, so everything in this triangle is congruent to the other part of the other triangle. So these two angles are what are congruent. Can we see them? Yes, guys. The first angle is this, and the second angle is this. The first one is EDG, and the second one FGD. This thing happened because we proved that these two triangles are congruent. So the angles EDG, 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 this one is congruent to the angle, it is written here, DGF, DGF, yes. So these two angles are congruent by using what? By using corresponding parts and two congruent triangles. They are congruent. And actually number 6 is what? Is alternate interior angles, and this is the converse of alternate interior angles, if you remember, and we say it. So guys, since that we have this angle with this angle, so that means, yes, this side ED and GF are what? Are parallel by using the converse of what? Of alternate interior angles. Now let me do for you exercise 2 on page 184. Here it is. As you see, guys, again we have an equilateral shape BCAD, quadrilateral, but focus again, we have two triangles ABC and ABD. Yes, guys, and we have here, it's given that AC is congruent to AD and CB is congruent to DB. So guys, we were here. So now it's given that AC and AD are congruent, CB and DB are congruent. So AC and AD are congruent and CB and DB are congruent. And he wants from us to prove that AB, the line AB bisects the angles CAD and CBD. In other words, what is the meaning, mister, that this line bisects? That means, in other words, in math, he wants from us to prove that this bisector AB divides the angles CAD and CBD into two equal angles. What does that mean, mister? Can you explain this on the figure? Yes, guys. First of all, the bisector is the line AB, and we call it a bisector because it divides the angle CAD and CBD into two equal angles. That means this angle will be congruent to this angle, and this angle is congruent to this angle. So again, guys, this is what we want to prove. To prove that AB is the bisector of these two angles, CAD and the angle CBD. To prove that AB is a bisector, yes, for these two angles, we have to prove that this angle, which is CAB and DAB, they are congruent. And on the other side, we have to prove that CBA and DBA are what? Are congruent. And this way we can prove that AB, this bisector, bisects the angles CAD and CBD. Okay, so let me continue. He said that to be more clear, CAB is congruent to DAB, and we talk about that, and CBA is congruent to DBA. So guys, let me start. Focus on these two triangles, ABC and ABD. What do we have? AC is congruent to AD is given. Yes, this is the side. And then 2CB, yes, is congruent. So the side CB and the side DB, yes, is also given. They are what? They are congruent, again, side. And obviously, guys, as you see, we have AB is equal or congruent to AB. It is a common side. So guys, come on, it's so easy that we have side. So we prove these two triangles are congruent. As we prove that these two triangles, CAB and DAB, they are congruent triangles by using side. We have the side AC with the side AD, they are congruent, it's given. And the side CB and DB, the other side, they are congruent, also it's given. And obviously that the side AB, yes, and congruent to the same side AB is common side. So guys, in this from 1 to 3, we prove that these two triangles, ABC and ABD, are what? Are congruent triangles by using SSS sides congruence. So from all of this, guys, so do you think we can use what we call it corresponding parts into two congruent triangles are congruent? Yes, guys, when we prove that this triangle and this triangle are congruent, so obviously we can use that one above that. Everything here, it will be what? It will be, yes, it will be congruent to the other one, yes. So obviously we can say that this angle from this triangle is congruent to this angle from this triangle. And again, the same, this angle from this triangle is congruent to this angle from the other triangle. Let me say here, yes, guys. So from all of these, we can say that from 5 and 6, the angle CBA is congruent to DBA. CBA is congruent to DBA. And also number 6, CAB and DAB are congruent. CAB and DAB by what? By using, yes, you are right, by using CPCTC. And this proves that AB, the side AB, yes, bisects these angles CAD and CBD. So to prove yourself, guys, please do for me number 5, number 6 on page 184 and number 11 on page 185. By this, guys, again, let me go again, 5 and 6 on page 184 and number 11 on page 185. So guys, by this we finish the first part of today's lesson, lesson 3, chapter 5. We finish from number 1, using corresponding parts. On the next video, we'll go to the second part and we'll finish by this lesson 3, chapter 5 on the next video. I love you so much and see you later. Bye, my dear students.